Okay, the next renderer I'll be covering in this tutorial series is the Vapor 3 image renderer. And previously I covered the 2D data renderer, and when I was doing that I explained that it's probably the simplest renderer to use in Vapor, but that's not true. The image renderer is even simpler, and so I figured that might be the best one to start with next. So let's dive in. Again, I am building Vapor from source, so I'm just going to go to my terminal and open the built version of Vapor that I have. But most users who install Vapor will have a little icon. After they install it, you'll find the icon in your installation directory. You can add it to your taskbar and just double click that. But we are actively developing right now, and so I have an active development branch that I'm going to run from my console. And here we see Vapor's default menu. Everything's disabled because I don't have data in yet. So I'll go to the File menu, and I'm using a VDC, Vapor Data Collection, of a WRF simulation of Hurricane Harvey. Most users will probably start by just importing their data if it's conformant to one of these formats, WRF A or W, that's CDF, that's CF compliant, or impasse. But I converted my WRF data into VDC that allows me to look at different levels of compression. And this is such a huge data set that I'm going to just render it at a coarse fidelity so we don't have to watch a screen load data for a minute and a half in the tutorial. So I've loaded my VDC data. I have my scene. I can rotate it with my left mouse button, zoom in and out with the right, traverse it with the middle. And what I'll do next is click on New, double click on my image renderer, and turn it on. So Vapor comes bundled with two georeferenced images. If your data has a prod string, and if your data is georeferenced, Vapor can associate the georeferencing information in your data to the maps that come bundled. And so getting a map that shows your viewers where your data is as simple as making an image renderer and turning it on. The variable selection is pretty straightforward. All you have is a height variable, and so for that I can click on HGT. And like the 2D data renderer, we can see that our height variable is applied to the small mountains that we see over here in Mexico. Again, this isn't the best data set to show height offset renderings, but I think it shows the point of what we can do. Below variable selection, we have data fidelity. I'm not going to increase the fidelity just for the sake of time, but right now we're looking at an approximation of our data. If I clicked on this, we would get a perfect reconstruction of the data, plus or minus floating point error, but it would take a while to load, so I'm not going to touch it. If you don't have VDC data, you'll just have one little button here and you won't be able to adjust, but that's okay for most users. Going over to the Appearance tab, the first item we have is the georeference checkbox, which is on by default. We can turn it off, and what this will do is it will just render an image of the entire world in our domain. So there's no georeferencing information, and the image renderer isn't really that useful without georeferencing information, so I'll turn that back on. Ignore transparency. Before I get into that, let's change our image file because first of all, I prefer blue marble for my renderings. So if I'll go back. I can select I can select any georeferenced image and have Vapor use that. Vapor comes with two. What we're looking at here is a product called Natural Earth, and the other product is NASA's Big Blue Marble. So if I double click that, here we have NASA's Blue Marble. So back to the Ignore Transparency checkbox. What we've done is we have applied an alpha channel to all of the pixels in our image files wherever there is a bathymetry or topography point below 0 meters ground level. So anything below 0 AGL has an alpha mask. We can ignore this and draw our oceans or anything below 0 AGL by checking this box. And there's the Gulf of Mexico that we can see. And turn it off. We can have all water bodies below 0 AGL turn transparent. And the reason for this is that our ocean modelers have to see what's below the water. All their simulations, are between the bathymetry and the surface of the ocean. So we have to turn off this water mask in the image. The last controller is opacity, and for whatever reason, I really never use this, but you can control the opacity of the image. The geometry tab works just like all the other renderers except for one caveat. What I didn't mention with the 2D data renderer was that if we look up here in the top left of the application, there's a drop-down box that says Navigate by default. If I click on that and select Region, we get these red boxes that encapsulate the area that we are drawing to. We can right-click on these boxes and constrain the region that is being drawn in the same way that we did earlier with our coordinate selector in the geometry tab. The image renderer has a unique behavior though, in that you can extend the region that you're drawing to outside of the domain of your data. You can't do this with other renderers because other renderers are directly drawing your data, not a map, and so there's simply nothing to draw outside of your domain. But the image renderer, you can stretch it out and give your viewers a better sense of where you are in the world. So I'll just pull this out, maybe get Florida and the Yucatan drawing, and I'll go back to appearance after this. I will not ignore the transparency, and here we have our first image rendering. Go back to navigate to get rid of my boxes, and here we have kind of a clean slate to start doing some more visualizations. With the upcoming renderers that I'll talk about, I'm going to be starting with an image renderer because I think it's a very important tool to let your viewers know where we are in the world. So with that being said, I will move on next to the contour renderer.